Resistors series. The property of a conductor to oppose the flow of charges through it is called resistance. In this experiment, our aim is to determine the equivalent resistance of two resistors when connected in series. Materials required: a meter bridge, jockey, Lagrange cell, resistance box, galvanometer, a key, connecting wires, a wire cutter, scale, two resistance wires or two resistance coils, and sandpaper. Procedure: first, make the connections as shown in the circuit diagram. Take a connecting wire and cut it using a wire cutter. Connect one end of the wire to the positive terminal of the Lagrange cell and the other end to terminal A of the meter bridge. Now, take another connecting wire and connect it between the negative terminal of the Lagrange cell and one end of the key. The other end of the key is connected to terminal B of the meter bridge with another connecting wire. Now introduce the resistance box in gap G1 of the meter bridge. Then take a resistance wire R1 and connect it to the gap G2 of the meter bridge. Since the resistance of the wire depends on its length, make sure that both ends of the resistance wire just touch on the gap. With other connecting wires, connect the positive terminal of the galvanometer to the central terminal of the meter bridge and negative terminal of the galvanometer to the jockey. Now insert the key and press the jockey near A and then near B. If the galvanometer deflections are in the opposite directions, then the connections are correct. Now press the jockey almost at the middle of the wire on the meter and introduce a suitable resistance R in the resistance box so the galvanometer shows zero deflection. Measure the distance 1 from terminal A to the balancing point. Then calculate unknown resistance using the equation R is equal to 100 minus L divided by L times R. Similarly, measure the balancing length and unknown resistance of another 4 nearby values of resistance R. Then take the mean of these resistance values, which will be R1. After taking these measurements, remove the key and then the resistance wire R1. Now take the new resistance wire R2 and connect it in the gap G2 of the meter bridge. Insert the key and repeat the same steps for finding out the mean resistance of the resistance wire R2. After taking the values, remove the key and then the resistance wire R2 from the gap G2. Now take two resistance wires R1 and R2 and connect it in series by joining the wires together. Introduce this combination in the gap G2 and insert the key. Calculate the mean resistance Rs for different values of R using the equation Rs is equal to 100 minus L divided by L times R. Then to verify the laws of resistance connected in series, calculate the theoretical value of Rs using the equation Rs is equal to R1 plus R2. If the experimental and theoretical values of Rs are the same, then the law of resistance in series is verified.